In this video, we are going to see how to find derivative of absolute value of x using limit definition. Okay, first let me define the function f of x that is equal to absolute value of x. Okay, now let me write the formula to get derivative of a function f of x using a limit definition. That is f prime of x equals to limit h approaches 0, f of x positive h negative f of x divided by h. So this is a formula we have to get derivative of a function f of x using limit definition. Okay, now what we have to do is we have to plug in the stuff for f of x positive h and f of x. Already we know that f of x equals to absolute value of x. Now to get the stuff that is equal to f of x positive h, we have to plug in this x positive h for x over here. Then I'm getting absolute value of x positive h on the right side. Okay, let me continue over here. F prime of x equals to limit h approaches 0. So now to get the stuff that is equal to f of x positive h, we just have to plug in x positive h for x over here. And here then I'm getting absolute value of x positive h for f of x positive h negative. For f of x, we know that absolute value of x, we can plug in this one for f of x divided by h. Okay, now we have to simplify this one and then we have to plug in the given limit for h, that is 0. In case without simplification, if I plug in the limit 0 for h over here, what will happen? Let me see what's happening. So absolute value of x positive 0 negative absolute value of x divided by 0. So absolute value of x negative absolute value of x, because x positive 0 is just x, we get absolute value of x over here divided by 0. Absolute value of x negative absolute value of x is 0, 0, 0, which is called indeterminate form in evaluating limits. Okay, so whenever we get indeterminate form as a result in evaluating limit, we should not consider this one as a final answer. So what we have to do is we have to simplify this expression and then we have to plug in the limit 0 for x. Okay, now how do you have to simplify this one? So for that, I'm going to consider the conjugate of the stuff in numerator. Conjugate means we just have to change the sign in the middle. So here we have negative sign. If I change positive sign, then I'll be getting the expression absolute value of x positive, h positive, absolute value of x. So this is a conjugate of the expression we have in numerator. Now I have to multiply both numerator and denominator of this rational expression by the conjugate of the numerator. Let me do it. So we get f prime of x equals to limit h approaches 0. So absolute value of x positive, h negative absolute value of x, it has to be multiplied by its conjugate, that is absolute value of x positive, h positive. We have to change the negative sign as positive. Absolute value of x divided by h times denominator also has to be multiplied by the same conjugate, that is h times absolute value of x positive, h positive absolute value of x. Okay, now what we have to do is we have to multiply this one and this one. When I consider these two expressions over here, it's in the form of a negative b, a positive b. Okay, now let me consider the algebraic identity, that is a square negative b square equals to a positive b times a negative b. Actually, this is called difference of two squares. The difference of two squares, a square negative b square, can be written in the factor form, a positive b times a negative b. We can consider this one in the reverse order, that is we multiply two binomials in the form a positive b, a negative b. So the first term over here, the first term over here are same, second term and second term are same. In the first binomial we have positive sign, in the second one we have negative sign. So here we have these two expressions are in the form of a positive b times a negative b. So to get the simplification of this one, what do we have to write? So when we have the product of two binomials a positive b, a negative b, it can be written as a square negative b square. Now to get the product of these two binomials, what we have to do is we have to write the square of the first term, negative square of the second term. Okay, now let me continue this on the next page. Then we get f prime of x equals to limit h approaches 0. So here in numerator, a negative b, a positive b. So we can write a square negative b square. A square means absolute value of x positive is the square, negative absolute value of x square. Let me do it. So absolute value of x positive, h the square, negative absolute value of x the square divided by h times. So we have to write this denominator as it is. Okay, let me write over here. Absolute value of x positive, h positive absolute value of x. Okay, let me close square bracket. Then we get f prime of x equals to limit h approaches 0. Okay, here, so the absolute value of x positive h is always positive because whenever we take absolute sign for any stuff, always it will result a positive value. And also when we have even exponent, always that one also will result a positive value. So here 2 is an even exponent. So this one will result a positive value. Since this even exponent will give a positive value for this one, we don't need this absolute sign anymore. So we can take the stuff inside the absolute value. Then I'm getting x positive h the whole square. The same thing. So here, since we have even exponent, always it will be a positive value. So we don't need the absolute sign anymore. We can take simply x square divided by h times absolute value of x positive h positive absolute value of x. Okay, let me do it now. F prime of x equals to limit h approaches 0. Okay, now let me consider the algebraic identity, that is a positive b the whole square, that is a square of the binomial. Its expansion is a trinomial, that is a square positive 2ab positive b square. So here I consider this algebraic identity to get the expansion of the square of the binomial over here. Considering this one and this one, we have x at the place of a and h at the place of b. So now to get the expansion of this one, we have to use a trinomial. So here at the place of a, we have to plug in x, at the place of b, we have to plug in h. Then I'm getting x square positive 2 times x times h positive h square. Here it's not multiplication, it's x, that is 2ab. Okay, negative x square. I'm taking this negative x square as it is, divided by h times absolute value of x positive h positive absolute value of x. Okay, let me close it over here. This x square, positive x square, negative x square will cancel out. Then I'm getting f prime of x equals to limit h approaches 0. We have 2x h positive h square in numerator. In denominator, we have h times absolute value of x positive h positive absolute value of x. Okay, now what we can do is we can factor h out in the expression in numerator because both the terms have the greatest common divisor h. So we can factor h out. Then I'm getting f prime of x equals to limit h approaches 0. We can factor h out. If I factor h out, then I'm getting 2x positive h in the parenthesis divided by h times absolute value of x positive h positive absolute value of x. Okay. So here this h and h will cancel out. Then I'm getting f prime of x equals to limit h approaches 0, 2x positive h over absolute value of x positive h positive absolute value of x. So that's all the simplification we can do. Now what we can do is we can plug in the limit 0 for x over here in this expression. So then we get 2x positive 0. That is, I plugged in this 0 for h over here. The same thing I have to do in denominator as well. That is absolute value of x positive 0 positive absolute value of x. Okay, here in numerator, when I simplify this one, I'm getting 2x positive 0 is 2x. So here absolute value of x positive 0 is absolute value of x. Okay, let me continue on the next page. Then we get f prime of x equals to, so in numerator we just get 2x. In denominator we have this one will become absolute value of x. So then we get absolute value of x positive absolute value of x. Then I'm getting f prime of x equals to 2x divided by absolute value of x positive absolute value of x will become 2 times absolute value of x. Okay, so here this 2 will cancel out and we get f prime of x equals to x over absolute value of x. Actually, we have defined the function f of x as f of x equals to absolute value of x. So for this f prime of x, what I can write is I can write absolute value of x prime. Let me write it over here. Absolute value of x prime equals to x over absolute value of x. Okay, now I got the derivative of absolute value of x using limit definition. That is equal to x over absolute value of x.